Okay, welcome student to part 4 of using green theorem to find the line integral. In this question, we need to use green theorem again to evaluate the line integral for this vector field along a curve C. So here we have to evaluate C f dot dr, which is, as we did before, this is just b dx plus q dy. And this is by Green's theorem equal to double integral. So this is equal double integral d of partial q partial x minus partial b partial y dA. So we take the first component and we find the derivative with respect to y and then derivative with respect to x. So here if we do it, this would be just 1 plus x squared dA. That's the integral that we get. Now, we have a problem of finding the double integral. So what we need is we need to sketch this curve and we see if it's type 1, type 2, and then we find the limit of integration. So we go to the next page. And here we have it. So my curve will start at 0, 0, 1, 1, 0, 1. So this is my curve going in this direction, and this is my function here. So here what we will do is either we deal with this as region of type 1, or we can deal with it as region of type 2. So let me just try to do it with region of type 1. Now, if I do it region of type 1, and let me just use different colors for different things. This one I will do it in orange, and this one I will do it in red. Well, the function in red is easy. This is y equal to 1. The function in orange, you can do it. This is y equal to x. Why this is y equal to x? How did I find it? I use this formula, y minus y naught equal m x minus x naught. So I get y minus 0. Now remember m will be, let me just do it here. It will be y1 minus y naught, x1 minus x naught. Now if we just substitute y naught to be 0, so we get 0, 0, x minus 0. y1 is 1, x1 is 1. If we do it, this will be y equal to x. That's how we get it there. So if we do the limit of integration, my x between two functions, the top function, which is y equal to 1, the bottom function is y equal x. Those are the two functions here. And my x will be from 0 to 1. Because if I put a rectangle, the top is red, the bottom is orange, and the rectangle move from the left from 0 and move to the right until 1. So the double integral d 1 plus x squared dx equal to, this would be equal to 0 to 1, integral from x to the red one, 1 plus x squared dy dx. And this is just integral from 0 to 1. Now this integral would be y over 1 plus x squared from x to 1 dx, which is the same as this integral will be 1 over 1 plus x squared minus x over 1 plus x squared. Those two integrals, we have seen them in calculus 2 when we did partial fraction. So this is tan inverse x minus this is half ln 1 plus x squared from 0 to 1. The final step, if we substitute 0, we get pi over 4 minus, if we substitute 1, this is half len 2. If we substitute 0, everything should be 0. So this is the final answer. Thank you for watching.